Alright guys, welcome to today's tutorial, and today we are going to be looking at the Laplace transform of sine and cosine. So we want to look at if we are given the sine of any value or the cosine of any value, how to find the Laplace transform of these values. So let's see, we have to look for the sine of, let's say, sine AT. Okay, so now let f of t be equal to sine AT. Find the Laplace transform. So we have to find the Laplace transform of sine AT. So the Laplace transform of sine AT. So the Laplace transform of sine AT will be integral of e raised to the power of minus st, then f of t dt. So what is our f of t? Our f of t is, of course, sine AT dt. Okay, so when we have this now, there's no way we can actually evaluate this with e. So what we are going to do is that, if you remember complex number, in complex number there's something we call the Euler form. The Euler form of a complex number is e raised to the power of I theta. So an e raised to the power of I theta is the same as cos theta plus I sine theta. If you remember, that's complex number. If you remember complex number, okay, we want to look for a way that we can convert, or we can make this equation, this one, to look like this. So in order for us to do that, we can actually say that e raised to the power of I at is equal to cos at plus I sine at. Okay, of writing, so we can go back to, let's call this one equation 1. Back to our equation 1. Now if you go back to our equation 1, you now discover that the Laplace transform f of t, which is integral of e raised to the power of minus st sine what? Sine at dt, is the same as e raised to the power of minus st multiplied by e raised to the power of I at. So instead of us writing sine, we'll write the whole of this. So now let's begin to evaluate. We have integral of, then discover that e is common. E is common to both. E is common, so we are going to pick one e. Using the law of indices, we are going to have minus st, okay, then plus I at, then dt. Okay, so which is going to be integral of, you discover that what's common here, minus into brackets, okay, minus s minus ia is common here. Ia is common into what? Into t dt. The Laplace transform will give us what? Integral of e raised to the power of what? Integral of what? Of e raised to the power of minus s minus ia, then to t dt. Now at this point, what we are going to do is that we are going to integrate. So if we integrate, we can say that by integrating, we can say let u be equals to minus s minus I at. Don't forget that the I is an imaginary number, so du dt will be equal to what? Will equal to minus s minus I a. Okay, then our du or our dt will be equal to minus du over s minus I e. So if you take it back to our equation, we are going to have the integral of e raised to the power of u, because we already said that the whole of this now is u, then the whole of this is u. So now then our dt is what? Is minus du over s minus I a. Okay, so what we are going to do is that we are going to take out the constant. So if you take out the constant, the constant is 1 over s minus I a, integral of e raised to the power of u du. At this point, you will integrate. So you will have minus 1 over s minus I a, then into, if you integrate, if you integrate e raised to the power of u du, what are you going to do? You are going to have e raised to the power of u, then close the bracket, you put your infinity here, you put your 0 here. So which is going to be minus 1 over s minus I a, then you bring back your u. Your u is what? Is minus into s minus I a, close brackets t, then you put your boundary infinity to 0. So at this point, you can begin to insert your value. That's minus 1 over s minus ia, then into e raised to the power of minus s minus ia, then the t now we put infinity in its place, then minus the lower boundary. So it's going to be the upper boundary minus the lower boundary, ia, then into what? Into 0. So now you discover that this will give you, so this will give you 0, the whole of this will give you 0, then minus the whole of this will give you 1. Okay, so which is going to be what? Minus, so minus times minus will give you plus 1 over what? Over s minus ia. So which is what? 1 over s minus ia. So at this point, what we are going to do is that we are going to rationalize. So you rationalize by the denominator. Okay, so you rationalize by the denominator. So if you rationalize by the denominator, we are going to have 1 over s minus ia, then multiply by s plus ia over s plus ia. So which is going to be 1 multiplied by s plus ia is going to give you s plus ia, then over s minus ia into s plus ia. Okay, so which is going to be s plus ia over s times s will give you what? X squared. S times this will give you plus s ia, then minus ia times s will give you minus s ia, then minus times plus will give you minus, I times I will give you I square, and a times a will give you a square. So you are going to have s plus ia over, that is x square, then you discover that this one minus this one will give you 0, then you'll be left with what? I square a square. And don't forget that s plus ia over, now s square minus, don't forget that I square is the same as minus 1 in complex number, so s plus ia over what? Over x square, then plus what? A square. So now what we are actually dealing with, don't forget that the formula we wrote was e raised to the power of iat is equal to what? Is equal to cos at plus I sine at. So now from this whole thing that we have now, so what we are going to do is that we are going to, since the sine, when you check this formula, you discover that the sine part is the one having the I, that's the imaginary number. So which means that for here, what you are going to write is going to be the imaginary part, so which is just going to be the a, not necessarily write the I. So x square, s square, then a square. So finally the Laplace transform, so the Laplace transform of sine at is equal to what? Is equal to a over s square plus a square. Okay, let's go for cos. Okay, so following the same process, now let's assume that our f of t, we are given that our f of t is equal to cos at, then the Laplace transform of f of t will be equal to integral is to infinity, then you are going to have e raised to the power of minus st, then cos at dt. Okay, so now what we are going to do is we are going to apply the same thing. So it's your e raised to the power of iat is equal to cos at plus I sine at, isn't it? So what we are going to do is this, we are going to say that, okay, that the Laplace transform now will give you integral of e raised to the power of minus st. Now instead of writing cos at, so you just write e raised to the power of I at dt. So we follow the same thing this way we did for sine. Okay, so which is going to give you e raised to the power of, then here you're going to have minus st, then so we have e raised to the power of minus st, then plus I at dt. So which is going to be integral of what? Of e raised to the power of minus, you open a bracket, then if you open a bracket, you discover that s is common, right? No, s is not common, sorry, minus I at ia, then t is common to both, so you do it like this. So So you follow the same process. You say if you're integrating this now, you're going to say let u be equal to, that is minus s minus ia t. So your du dt will be equal to what? Open bracket s minus ia, then your dt will be equal to minus du over minus s minus, oh sorry, not a minus again, we already take the minus up here. So at this point you can bring it back to your equation. You have infinity, then you're going to have e raised to the power of u, then what's your du, what's your dt? Your dt is minus du over s minus ia, so which is equal to minus 1 over s minus ia integral of what? Of e raised to the power of u du. So at this point you can integrate, so you have minus 1 over s minus ia, then if we integrate e raised to the power of u, you are also going to have the same thing. So you put your boundary infinity to 0, so you have minus 1 over s minus ia. So now what is your u? You discover that your u is what? Is minus s minus ia. Okay, good. So then infinity, you have 0. Okay, you put the boundary. So here at this point you are going to, okay, into the place of t, so you're going to have minus 1 over s minus ia, then into e raised to the power of minus into s minus ia, open another bracket, we have infinity, then minus e raised to the power of what? Of minus ia, then you put 0. Okay, so which is going to be minus 1 over s minus ia into this one will give you 0, then this will be what? Minus 1, you close the bracket. So now what you are going to have is what? Is minus 1 over s minus ia, then multiply by minus 1, so which is going to give you what? 1 over s minus ia. So at this point you rationalize, so you rationalize. So if you rationalize, what are you going to have? You're going to have 1 over s minus ia multiplied by s plus ia over s plus ia. Okay, so which is going to be s plus ia over s minus ia, then into s plus ia, close the bracket. So if you rationalize, we are going to have that is s plus ia over s minus s plus ia, then into s minus ia, whichever one you want it to. Is going to be s plus ia over x squared, then plus sia minus sia, then minus I square a square. Okay, so which is going to be s plus ia over, that is s square, then minus I square a square. So which is going to be s plus ia over, that is s square minus, you know that I square in complex number is minus 1, then a square. So which is going to be s plus ia over s square plus a square. So don't forget that what we actually did was the cos part, right? So and the cos is the real number. So here this one is having the imaginary, so this is the real, so which means that you are simply going to omit the imaginary part. So it's going to be s over s square plus a square. So therefore the Laplace transform of cos at is equal to s over x square plus a square. So thanks for watching.